Hello friends, welcome to the new semester. Now in this semester we will study the subject control system, and the first lecture is introduction to the control system. Now a control system is actually represented by a block here, okay, and in this case this system may be any combination of an electrical components, or it may be an electric circuit, or it may be a mechanical system, or it may be an electronic system, or it may be a combination of about, or any other system in which the dynamics of the system, that is, you can say that output, that is also known as your controlled output, is controlled by some reference input. In this case, this reference input is denoted by RT, or a small RT, you can say that, and the output is denoted by CT, okay, where R is a function of time and C is the function of time. In this way, you can say that your system is actually controlled with the help of the reference input, and so that we get the desired output. Okay, take an example of an electric circuit. Suppose there is a circuit consisting of R and C here. Okay, and if we consider these two terminals, that is terminal 2, port 2 as output and port 1 as input, then this becomes a system. Actually this is an electrical system here. Okay, now this system is represented by its transfer function, like this. Okay, where we have to show it like this. This is your port 1 V in, and this is your port 2 V out, and here we write its transfer function, and transfer function is nothing but is actually the V out divided by V in. It is the ratio of V out by V in. Or if we write its transfer function in terms of S domain, that is nothing but its Laplace domain, then we can write this Ts as is equals to V out S divided by V in S. Now if we convert this circuit in S domain, then we will get the following representation here, like this. This is your R, and here we connect a capacitance C, and we can write it in its Laplace domain form, that is 1 by SC, and this is V out S and V in S. Okay, so if we write its KVL here for this loop, and assuming that this current is your IS here, then V in S is equals to R plus 1 by SC into IS, equation number 1. And if we write second equation, then we will get the second equation as V out S is equals to IS into 1 by SC. If we find out its transfer function, that is also known as gain here because it is a ratio. Okay, so you can also denote it by GS or TS. You can say that transfer function is the total transfer function, and okay, then in this case this will be V out S divided by V in S, and this will be equal to your equation number 2 divided by equation number 1, and that is nothing but that is 1 by SC divided by R plus 1 by SC is equals to 1 divided by 1 plus RCS. And if we write it in this form, then you can also replace S by j omega, and then this will become 1 divided by 1 plus j omega RC, and this is the transfer function of this system. So we can represent this system with this block like this, such that it has an input V in S, and this is here TS, and we can control our output V out S. So in this case you can say that this output is actually controlled by the input V in this way, in such a manner that V out S is equals to TS into V in S. Okay, so this is an example for a control system. Now let's move ahead, that which books or textbooks you have to refer for it. That first book is your control system engineering by I.J. Nagarath and M. Gopal. This is a very good book here. You can refer it for most of the syllabus. Second is we will follow the book Linear Control System by B.S. Manke. Okay, you can use this book for numerical purpose. Okay, now we will continue to the next topic, that is open loop control system versus closed loop control system. Okay, see here what is the difference. Now in case of a open loop control system, your system looks like this, that there will be no direct connection or indirect connection between the input and output. That is, there is no mean or way is available to watch, to have a watch on this output, that is what is actually the output for a given input. We cannot see it. Okay, we have to just apply the inputs and just the output will come according to the input, but there is no means by which we can control this output or see this output, so that we can manipulate our output according to our requirement. Now suppose if there is a change in the system due to temperature or pressure, this output will change. Now in this way you can say that this system is not reliable itself. Let us suppose some fault occurs in this case. Let us suppose some temperature change occurs in this case. Let us suppose some pressure change occurs in this system. Then due to these parameters, your output will change, and your input cannot have a knowledge that output is actually not the required output, because the parameters are changed here. Okay, now the second is your closed loop control system. That is, in which this system output CS is given as a feedback with some feedback circuit, and after examining the difference between this input and the feedback input, the error signal is provided to the system. This type of system is actually your closed loop control system. Okay, now there are some advantages and disadvantages of open loop versus closed loop control system, and these are as follows. Open loop control system, and the second is closed loop control system. Okay, first one is, they are actually simple and most economical, because the circuit or block is very small, then it is very economical also. This on the other hand has complicated to construct and costly. Okay, second, they are actually less accurate, because there is no feedback is provided from output to the input, and input signal does not have any information that what output is currently present at the output pin. So these are actually less accurate, and these systems are more accurate, and actually this is possible because your output is continuously compared with the desired value, and the control action works to reduce the error signal, so more accuracy is there. Okay, third, simple in construction, so there is less stability problem. Okay, whereas on the other hand, due to complicated circuit, complicated structure, these types of systems becomes sometimes becomes unstable. Okay, now fifth, that is, these are more sensitive to the external parameter change, such as in this previous case, that is like this, जो हमने अभी यहाँ पे देखा था, that is fault, some fault occurs there, some temperature or pressure changes there. Due to these external parameters, your output will change instantly. Okay, so these are more sensitive to the external parameter changes, and these are less sensitive because they correct themselves by these systems correct themselves as there is a feedback is provided from this output to the input side. Okay, now the sixth one is power requirement is less as the number of components are less. less number of components are required. Whereas in this case, more components are required. So open loop systems required less power, and your closed loop systems required more power. Okay. Their speed is actually slow. Slow speed of operation, because to achieve a desired result we have to proceed slowly towards the output, desired output. So we have to maintain a slow speed, otherwise your system may enters into the unstable region. Okay, whereas in this case it achieves very fastly the desired response. Okay, now take an example. If you are driving a car here, okay, if you are driving a car here, and it does not have any speedometer there, then what will happen? You just have to control your speed by either controlling your movement on speedometer. Okay, whereas if it if the same car is provided with some speedometer, then continuously watching on the speedometer you can maintain the required speed according to the requirement. This type of system is actually a feedback control system, or you can say that closed loop control system, and this is your open loop control system. Okay, now in next class we will study the introduction to the Laplace transform. Okay, thank you.